Hello, my name is Peter Gog. I am the Forest Health Manager for the North Dakota Forest Service. And today's presentation is about what trees can tell you. So there are a lot of possibilities here. We'll try to take a look at some of the more commonly seen situations in our landscape. So most of the items will be adapted to more appropriately fit the circumstances that we see in North Dakota. There are two types of visible indications that present on a tree that will tell you something is not right. These are considered to be either signs or symptoms. Signs are associated with the organism that is causing an issue, either an insect, a fungus, or potentially a bacteria. The signs of these biotic disturbances are usually a direct product of the organism's behavior, which are things like particular leaf damage, beetle galleries, excrement, or actually seeing the organism itself. Signs that pertain to insects and disease issues are generally indicative of a particular damage agent. Symptoms, on the other hand, are the tree's response to a damaging agent and can include things like senescing leaves or limbs, splitting bark, discoloration, or thinning of foliage. But symptoms do not need to be specific to a particular damage agent, since abiotic issues and damaging agents can bring on similar symptoms. So signs are specific to an organism, while symptoms are not. There is an assortment of potential stressors that can cause signs and symptoms to occur on a tree or a grouping of trees. Now, these stressors stem from abiotic causes, which are broadly site or environmentally driven, or from biotic causes, which would be a specific organism. Now, since North Dakota's landscape is generally described as prairie, it fundamentally does not receive enough moisture to grow trees vigorously. So when we are considering abiotic stresses, it is often safe to assume, unless we are experiencing above average rainfall during the growing season, that there is a shortage of water. Water is almost always going to be limiting in North Dakota. When we start considering the other abiotic variables like weather extremes, the airs from planting, or the land use activities that disrupt a site, we start seeing the complications with maintaining vigorous tree growth. The loss of vigor is what allows the secondary biotic health issues to become pronounced. These secondary issues will almost always stem from abiotic challenges. So the weather and the site variables are the long-term issues that need to be carefully considered because they create the circumstances that encourage the insect or disease issue in the first place. Regardless of site conditions, tree vigor is always in a state of flux as resource availability is altered because of changing growing space and varied weather conditions. There are two general trajectories that we see with tree health, the chronic and the acute. In North Dakota, lacking water availability becomes a chronic tree health issue, causing decreasing growth rates with increasing tree height, which leads to an overall decline. We often see these consequences as short internodal growth length, causing a distorted appearance to the ends of branches. Acute decline is a much more sudden tree response that often occurs in association with an event during or surrounding one growing season. Acute decline can be from storm damage or flooding or construction damage, all causing significant damage to a tree's structure or physiology. Insect and diseases will rarely cause acute decline without significant loss of vigor, allowing these agents to become rapidly established. On this slide is a tree decline recovery seesaw from White et al. 2006 that views drought stress as the driver that influences the state of tree vigor and how these changes in vigor create opportunities for insects and disease agents. With moisture availability being a major driver of vigor in North Dakota, we can assume that water is frequently at the center of our tree health issues. That doesn't mean we can't water a tree to solve its problems, but it does mean that assuring water availability through appropriate management can help limit the loss of vigor. It's also important to understand that as a tree grows, its resource demand increases, which is why we often see chronic tree health decline. Tree decline is often signified by crown dieback, which is the general term for symptoms of senescence of branch tips and branches in the crown. When it occurs in the outer and highest portions of the crown, it often has to do with hydraulic limitation caused by a lack of water to those locations, which is complicated by soils, available moisture, weather, or simply the path length from soil to the leaf. The rate at which dieback occurs usually depicts the cause. In North Dakota, slow decline and dieback in older, well-established trees is often driven by chronic abiotic stress, as previously mentioned. Acute dieback is more likely to be caused by insects or disease in conductive tissues, exacerbated by hydraulic limitation. Dieback from insects and disease is often seen in individual branches or more isolated portions of the tree. In many North Dakota forests, it's common to find dieback caused by chronic hydraulic limitation, followed by a weakening of the tree, which then encourages the establishment of our endemic forest insects and diseases. It is rare not to find that both abiotic and biotic stressors are responsible for well-advanced chronic dieback in our larger community and natural forest trees. Abrupt changes in physical leaf appearance can be caused by an assortment of variables. The most frequently experienced change in appearance would be wilting caused by the loss of water pressure in the leaf. This most frequently stems from a lack of available soil moisture, an organism disrupting the water-conducting tissues somewhere between the root and leaf, or chemical damage. If the wilt is drought-driven, it is more likely to appear more or less uniformly throughout the crown. Drought-driven wilt in deciduous trees can be corrected by supplemental watering, and should be relatively obvious when considering the amount of received precipitation over the season. If it cannot be corrected with watering, then it is another biotic or abiotic issue. The same hydraulic limitation in conifers leads to needle senescence, which are then shed and cannot be corrected by watering. Abiotic wilting can be caused by structural damage from a recent storm, soil compaction, or construction activities. Biotically driven wilt is more likely to affect specific parts of the crown. If the wilt occurs on an individual branch, where it is more likely to be caused by an organism within the conducting tissues to that branch. If an individual branch is affected, it often progresses to foliar discoloration and senescence of the leaves and eventually that branch, which is referred to as flagging. If the wilt is chemically induced, it either systemically entered the tree through root exposure or was indirectly applied to the foliage because of drift or volatilization. If it was indirectly applied, this is more often affecting a portion of the tree, such as the upwind side or the lower branches. If the chemical damage is throughout the crown, it was more likely a systemic exposure through application that reached the roots. As you can imagine, foliar damage also has many causes, so a lot of time could be designated here. Instead, I'll focus on a few types of damaging agents that can be associated with chlorosis or discoloration, often seen in North Dakota. Chewing insects have three prominent signs based on their methods of consuming leaf tissue. First, there are the general chewing insects that make holes or reduce the leaf from its margin inward. Most of these we see in North Dakota are the larval states of lepidopteran species or moths. The second are leaf miners, which feed within the upper and lower leaf epidermis, causing portions of the leaf to become opaque. Lastly, there are skeletonizers that eat the more palatable leaf tissues, leaving behind the leaf veination. So another leaf predator are the sap-sucking insects, which often produce galls and stippling on a leaf as they feed. A prominent sign of the presence of many of the sapsuckers is honeydew, or the sticky clear excrement falling from the tree. You can usually see this on cars or sidewalks, other surfaces below the tree. Galls are a deformity that develops as some sap-feeding insects disrupt plant growth hormones. Particular galls become a distinctive identifier of the insect feeder. Stippling can also identify the culprit as tiny injuries develop at the feeding site, causing leaf surfaces to become textured and speckled. Mottling, spots, or blotches present as undefined patterns on leaf surfaces. Most of this type of damage is caused by fungal or bacteria infections to the leaf. These organisms spread to other leaf surfaces by moist conditions, meaning these are generally not issues that become pronounced when we are experiencing dry growing conditions. Not all leaf mottling is associated with fungi and bacteria, so some is also abiotic. Damage to the leaf margin, for example, is a drought-related symptom, often seen in our landscapes during very dry growing conditions. As for discoloration, our most commonly seen issues relate to the availability of manganese or iron in fine-textured, high pH soils. These conditions cause yellowing or chlorosis to the foliage of often birch and maple trees because these nutrients become unavailable in high pH circumstances. Otherwise, most discoloration that we may find is related to abiotic variables, such as water or soil conditions. So as a general rule, it's more likely that insect issues become prevalent during periods of drought, and fungal and bacterial infections are more pronounced during moist conditions. This can also be a rule in relation to irrigated sites where moisture is maintained regardless of seasonal precipitation. We see an assortment of bark injuries to trees in North Dakota, so it's important to understand that mechanical damage, whether from hail or human actions, creates openings through the bark to the conductive tissues, creating the opportunity for long-term health challenges. When a fungus or bacteria can become established in these bark openings, a canker can often form, which is generally a dead area within the bark. Cankers can disrupt the conductive tissues of the tree, causing distal tissues to decline. Vulsa canker is a good example of this. It's commonly found on spruce, forms a girdling canker that commonly leads to individual branch senescence. Most bark damage from insects will come from wood and bark-boring beetles. Common indicators of wood-boring beetles are going to be exit or entrance holes, pitch, frass, or sawdust that is associated with the boring. The other key that may bring you to check for these signs would be flagging in the crown, where a branch or a small portion of the crown develops senesced leaves. Detached bark is commonly seen with many of our declining community and windbreak trees. There are two reasons for this. One is the presence of beetles boring in the cambium under the bark, causing the bark to separate. The other may be caused by mycelial fans forming in the same conductive tissues, but near the bottom of the tree. These fungi also cause these tissues to separate and the bark to peel away, but generally come from root disease. Bacterial wetwood affects many of our deciduous tree species, but is very commonly seen in elm and cottonwood. When a wound in the bark is created, the bacteria can enter and generate an exudate that ferments, and it builds pressure under the bark and causes liquid to excrete from the wound. This process mildly influences the central core of the tree, causing a very slow decay. There is no effective remedy other than maintaining the tree vigor. And you can often see that bacterial wetwood is occurring in a tree by a burn in the grass or a bleach spot on the concrete. So in summary, there are two takeaways and two general rules that should help guide some understanding of tree health issues. Now, starting with the takeaways, The first is that the presence of many health issues can be decreased by assuring adequate available moisture. Generally, if disease or insects establish into a tree, there has been some degree of environmental stress put on that tree, and water is usually the place to start. The only time this is not the case will be during springs or growing season when precipitation and soil moisture are normal or above normal. This will also depend on the topography and how the water moves on the landscape. Now, since we are focusing more on plantings, the second takeaway is the need to control the abiotic conditions of the site. Now, this is done by choosing the appropriate site before planting, considering things like topography, salinity, land use, and chemical applications. Understanding these challenges and limiting their influence is important for tree health. Likewise, correcting these issues, if possible, for an existing planting can encourage tree vigor recovery. As for the two general rules, these will almost certainly be secondary to addressing the two takeaways. Once that is accomplished, it's important to understand that insect issues become more prevalent during periods of drought, and fungal and bacterial infections are more pronounced during moist periods. Now, this can also be considered in relation to irrigated sites, where moisture is maintained regardless of seasonal precipitation. In some cases, a moist period that spreads fungal spores can be a matter of hours at the correct temperature. The longer that period, the more pronounced the issue will be. But generally, dry periods of time encourage insects, moist periods encourage fungal infections. So I'm hoping that gives a little bit of potentially review or new information to help guide you in looking at tree issues. So I just want to thank you again for listening, and this will conclude all information I have for you today. On this slide, you'll find my contact information, so please feel free to follow up as issues arise. Thank you.